Alright guys, let's talk about the 4.4 to 4.6 test that you're going to be having. I wanted to start with looking at a few like delta maths because remember we talked about how on your test the first few questions are going to be logarithm questions that you do without a calculator. Alright? However, I will have that on the board for you. So you have a list of all your facts, you got to do these. Okay? Now look, if it's something, off the list, log base 2 of 64, when I look at my facts here, it only goes up to 2 to the 5th is 32, but then you just know 32 times 2 is 64, so it's 2 to the 6th, right? So then I just say that that equals 6, okay? This type of thing is going to be on there because that's one of the identities we know when it's log base b of itself, right? Anything to the 1 is itself. So we're going to have some questions like that. 6 to the what is 216. So I look at this. I go and find it. It's right here. 6 to the 3rd is 216. Right? And I just go, that would be 2 to the 3rd. Okay? So we're looking for these exponents that way. 3 to the what is 243. Alright, I come over here. 3, boom, boom, 243. It's right there. 3 to the 5th. Okay, we've been doing these. I think you guys will be fine. Now, where they get a little tricky, and I sometimes have to like advance through a few until I find one that works. Okay, something like this. Log base 16 of 2. Now, okay, on our chart, I know from right here, 2 to the 4th is 16. But this is asking me go 16 to the what is 2. All right, so I'm doing like this. 16 to the what is 2. Well, the way it works is if 2 to the 4th is 16, to go the other way, 16 to the 1/4 is 2. Alright, so that's how we go back and forth with that. I think most of you guys have been doing that. Okay, so you use 1/4 when you're going from a bigger number to a smaller number. Let's see if I can find another example. So 16 and 1/4. Okay, this is a great example actually. Alright. So I know over here, 4 squared is 16. Okay, so I'm using that one. 4 squared is 16. Okay, so I go like this. 4 squared is 16, which means 16 to the 1/2 is 4. But then you guys, whenever you make it a fraction, you need to go negative because it's going to 1/4. That's basically as difficult as that's going to get. Okay? A lot of these we can't do. 16 and 2. 2 to the 4th is 16. 16 to the 1/4 is 2, so it's 1/4. But then it's negative because one of them is a fraction, right? We'll just do it like that. Okay, so hopefully you guys feel fine with most of that. I think that's going to be okay for you guys on your test. All right, so you're going to start off with a bunch of questions like that. Okay, and then I'm going to go through this review backwards, I think, a little bit, because the graphing part is also going to be on the no calculator part of the test, the same as what we were just like going through there. So I want to do these with no calculator. All right? Okay, now, the way I'm going to have it set up is, whatever this number is, I'm going to have it like this. 1/2 to the x and a little table for you to fill in. And then log base 1/2 of x and a little table for you to fill in. Okay? So you do that first. Now, if it is a fraction, I want you to use 3 points. Okay? We use -1, 0, and 1. Because we know 1/2 to the -1 is 2, and that's an easier number to plot. 1/2 to the 0 is 1, and 1/2 to the 1 is itself. Now, when you put it in the log table, all you have to do is flip those numbers around. Okay? And that's my parent graph. So what I'm going to do now is I'm going to draw an asymptote. Now, it always starts with that going right down the middle. And my 3 points on this one, which are 2, -1, 1, 0, 1/2 1. Okay? Alright, now I gotta erase some of these real quick because we are only doing domain range asymptote. So let me get rid of this. Alright, But I am going to have a line that says, transformations. All right, and you're going to list the transformations. Now for this one, okay, here's my parent graph. So now how am I gonna move that? Well, remember that if it's on the inside of the parentheses, it's left or right, and it's opposite. If it's on the outside of the parenthesis, like number 2, it's up or down, and it's same. Well, the +3 on the inside being opposite means it moves it to the left 3. And then the negative in the front flips it upside down. The negative on the inside over here flips it left to right. Okay, so these are all the things that you really need to know. This one doesn't have an example of it, but remember, if there's a number in front, like a 3 or something, it just means multiply the y values by 3. All right. So let's go ahead and do this. Now, I like to start with my asymptote. Okay, flipping it upside down is not going to do anything for my asymptote, but moving it left 3 is, okay? Okay, now, I'm going to do a set of points in between. Flipping it upside down, this point will stay there. This point down here, okay, moves up to here, and this half point right there moves to there. And then I'm not going to draw this one. I'm going to go ahead and go left 3. So I count 1, 2, 3 from here, 1, 2, 3 from here, and then from the half, 1, 2, 3. And that's it. And then I just go ahead and graph it. Okay, so you can kind of tell it's flipped upside down. It's gone left 3. To write my information, remember domain is how far left and right it goes. So to that asymptote. Well, that asymptote is at -3, and then it goes all the way to infinity. Okay, the range is -infinity to infinity. All logarithms have a range of -infinity to infinity, and the asymptote is at x equals -3. Okay. Okay, so let's look at this next one. Now, this is log base 2. So over here, what I will have for you is 2 to the x with a little table, and then log base 2 of x with a little table. All right. Now, 2 to the x, I'm just going to use 0 and 1. 2 to the 0 is 1. 2 to the 1 is itself, which means log is 1, 0, 2, 1. Okay? So when I draw it, I start, my initial asymptote is right down the middle. And my points are at 1, 0, 2, 1. All right? Make this a little bit lighter so I can transform it. Okay, now, my transformations for this one are, remember on the outside it stays the same, okay, it's up 4, and on the inside is where it flips it left to right, okay? So I'm going to go ahead and do the flip first. That point would stay, actually both points would move. That point would move over here, that point would move over here. So you guys like kind of picture, it just goes all the way over that way, and then we're going to go up 4. So there, and there. And the asymptote didn't change at all, okay? I mean, you don't have to redraw it, but it is going to be right through there. All right? And so my new graph is flipped and up 4. And so it kind of like looks like this. All right, now I'll just like check your points and all that stuff. Okay? And then we go back here and we say, well, what's the domain? Now, this one's interesting because it's fully on the left side of the graph. So my domain actually goes -infinity until I get to 0. My range is -infinity to infinity. And then my asymptote is still at 0. It flipped, but it didn't change. Okay? So about a third of the points on your test come from graphing. There's going to be 4 questions on there. And the only transformations are going to be flipping it up and down, which is a negative in front, flipping it left to right, which is a negative on the inside with the x. I'll have left and right shifts and up and down shifts. Remember, inside is left and right, and it's opposite. Outside is up and down, and it's the same. And then, like I said, I think there is one question on there where I have like a 2 in front or something. And then that just means you go over here and multiply your y values by 2. All right? And that's going to be like a third of your test. Okay, then when you're done with that, you're going to go ahead and you're going to get the calculator part of your test. All right? And that's where we're going to work on these things like equations and then also properties. All right? Okay, with equations, when you are going from logarithmic form to exponential form, you do this little circle thing, right? Boom, boom. It just wants the equation. You're not solving anything. So 2 to the negative third is 1/8. Now, the thing that's kind of nice is it will make a true statement, you know? So you could see 2 to the third is 8, and it drops it down on the bottom as 1/8. That's a true statement, okay? This one, when there's no base here, you guys remember we put a base 10. All right, so then this one goes 10 to the 2 is 100. Another true statement, so that's good, right? 10 squared is 100. And then the last one, this won't really make a true statement because it's got an x in it. That's okay, though. Whenever you see an ln, you're going to use e, and you're going to go like this. And so it's e to the x equals 7. Okay? Perfect. All right, now, the next ones, you're writing them from exponential down into logarithmic form. I think this one's a little harder. The way that I would do this is I would remember that it's always going to equal the exponent. Because that's the whole point of logarithms, is to equal the exponent, okay? And when we say it, we say log base. Well, it's clear that, like, that's the base, because that's what's to the exponent. So that's how I remember. Log base 32, put the 16 there because that's the only place for it to go, is 4 over 5. Okay? And then, you know, if you want to, like, kind of check it like that, you can check it and make sure you did it right. Like, okay, it goes 32 to the 4th is 16. So the arrows will help you, like, check that. All right? This would be log base e. Now, as soon as you realize you're putting log base e, you're like, oh, yeah, we call that the natural log. So I change it to ln, so I don't have to put a base e anymore, of x equals 4. I'll write that one like that. And then this is log base 10 of 10,000 is 4. And again, with 10, you don't have to write it either, and you just write log. That one's like a little more optional. You can write it or not. But e, you really need to switch it to ln. Okay? Writing back and forth is fine. Now, this type of question would be on the no calculator part of the test, okay? And these two would be on the calculator, where it would like literally say, use your calculator to find. Okay, on the no calculate part of the test, you would go like this. Well, 1/2 to the what is 16. And the fact that I'm using off of here is this one. 2 to the 4th is 16, right? So I go, if I know 2 to the 4th is 16, I know 16 to the 1/4 is 2. Oh, but I'm actually not going that way. Never mind. I don't need that one. If I know 2 to the 4th is 16, but it comes up off the bottom of the fraction, that's going to be -4. That's how we do that one. Okay? Now, when I do them with the calculator, I will show you the 2 ways to do it. As long as you know how to do it on either one of my calculators or Desmos or whatever, you'll be fine. So, let me pull up my calculator. Alright, so on my calculator, you find log base by going under math on these graphing ones. You scroll all the way down to letter A. It's like 90A, and it's log base. You hit that, and then you can go log base 14 of 28, and that's your decimal. We're going to go to 3 decimal places. Now, I don't care if you round or if you just cut it off after 3, it's fine. So you can either write for your answer for this. All right, so for this, you know, I would accept either 1.262 or 1.263, like that's fine. Or you can put down more decimals, and that's okay, as long as we're not having to round to a specific number. Okay, and then let's take a look at the other one. So ln on my calculator is right here. Then I just go ln 36, and then log base 10 is like right above it. Okay, so that one is 3.583, or I would accept 3.584 if you're choosing to round. Okay. All right. On Desmos, let me go ahead and show you where you would go for evaluating. Okay, bring this like keyboard up, and then over here there's a thing that says functions. My face is in the way. Alright, so I hit functions, and you scroll down to where it says calculus. Alright, and we have ln, log, and log base a. So if you pick that one, then it allows you to type in like log 1428, and it will give it to you. Okay? Or scroll down again into calculus, log base a. Oh, actually the next one was ln, sorry. But ln is in the same place. Yeah, it was ln 36. So I just scroll down to calculus, I go to where it says ln 36, and there's my answer. Okay, so Desmos is really easy to do it as well. Alright, perfect. Okay, let's go into properties now. Alright, now guys, when you are condensing, that means we're putting it all together, right? The first thing that you want to do is bring these numbers up, okay? So that third will come up, and then, I'm kind of like, get rid of it so you can see that it's not there anymore. Okay, great. And then, this 7 will come up, right? Okay, so it's log base 2 of x to the third minus log base 2 of y to the 7th. Okay, now when I put them together, because it's a minus, you have to divide. Okay, so I go log base 2 of x to the third divided by y to the 7th, putting it all together. Alright, look at this next one. Now, I'm going to bring this 2 up, and because of the parentheses, I need to actually do it to both of these. Okay, so this becomes log 64, log 64, and this becomes log x to the 8th. Now, because of the plus, when I put them together, right, so this one was the minus, the plus, I'm going to multiply. So it's log 64x to the 8th. Alright? Okay, next one. I'm going to bring that up to the 1/3, and I'm going to bring that up to the 1/2. So those both go away. Alright, so this turns into ln of p to the 1/3 minus ln of 100 to the 1/2. Now, remember, these things mean third root and square root. Now, when I put it together, because of the minus, I'm going to divide. So I'm going to put ln of, and then p to the 1/3, I'll go ahead and do cube root of p. And 100 to the 1/2, well, if that's the square root of 100, I can just go ahead and put 10. Alright, now this is actually optional. You could totally just leave it as p to the 1/3, that's fine, but we just want to put those together. And then the last one, kind of already put these square roots on, so all I need to do now is combine them together by dividing the square root of 84 divided by the square root of 7. Well, because they're both in the square root sign, you can just do 84 divided by 7, right? So if I do that on, well, I'll just use Desmos, I was going to use my calculator, but anyways, I get 12, okay? So this just turns into the square root of 12, and then that's like good enough. I can leave it like that. All right, cool. So that is condensing. Okay, So, box my answers, I forgot to do this. You're just kind of making sure that they're all in a single logarithm. There's no exponents in front. Everything is all like combined up together. Okay, now with condensing, we're doing the exact opposite. We're like separating them out. Okay, I would have written this with parentheses right there. I feel like it's a little more clear. All right, with that being times, I would separate it to log 5 plus log y to the x minus 1. And then we're doing the opposite, so any exponent actually comes down the front. So it's going to be log 5 plus, and I do need to probably put that in parentheses, x minus 1 log y. Okay, and that's fully expanded. Okay, the next one, this is a great question because I have a multiply and a divide. So this is a very, very good question. Okay, so when I separate it out, it's log 2 plus, let's see here, log square root p minus log q to the 7th. Well, any exponents, like the 7 will come down in front. And this square root is actually a 1/2. Remember, square roots are 1/2. And that can come down in front. Okay? So here's how I would write this. I would say log 2 plus, I would bring the 1/2 down in front, log p, minus, I would bring the 7 down in front, log q. Okay? Okay, now, this one's a bit tricky. What we have to do is we have to factor this before we can separate it, because you can't separate out something that's just like minus in there. So this is actually, sometimes I put brackets when I put parentheses, it's a little more clear. 2x plus 1, 2x minus 1. And there's a multiply in the middle of that, so now I can write it out. Log base 8 of 2x plus 1 plus log base 8 of 2x minus 1. Okay? And then that's expanded. And then this one, we talked about in class, you know, it's divide. If you just want to expand it and like put a minus in between, that's fine. I don't think I'm going to give you anything quite this tricky, but like 5x minus 20 is the same thing as 5 if you factor it out, x minus 4. So I think that's probably what they're looking for. So there's a times and a divide. Okay, I would just give it to you the second way though. So it would go like this: log 5 plus log x minus 4 minus log 3x. Okay, and there's your answer. All right, so that's what expanding looks like. Okay. Now, again, I told some of you guys this, but you can actually have ChatGPT make you some practice questions if you feel like that was not enough practice questions, okay? I think that this is a really useful tool that you can use for, like, I don't know, learning math, making more practice problems, and not just, you know, using it to, like, try to cheat or whatever. So you could say something like, give me 4 practice problems for expanding logarithms. All right, why am I spelling like everything wrong? It actually doesn't care if you're spelling it wrong. I'm just embarrassed because you know. Okay, give me 4 practice problems for expanding logarithms. Boom, there's one. That's a really good problem. There's one. That's great. Boom. Okay, and then, you know, it gives you like the properties and stuff. Let me know if you need hints or solutions. So, you know, you could like practice these, you could write them out or whatever, and then you could be like, okay, answers, please. You don't have to ask it, please. I'm just polite. You know what I mean? And then it'll just like go through step by step how you would separate it out, how you would bring down the exponents, right? And then like it will give you your final answer. So it's really a tool that you guys can use. You could do, give me 2 practice problems changing from exponential form to log form. I'm even just going to put log form, and it knows what I mean. Sure, here we go. Boom, boom. Write those in log form. You know, it's great. These are like really, really great problems. And then you can like write them out, try them, and then let me know if you want the answers, and put that in there. Okay? Okay, so anyways, guys, use this as a tool if you want to practice. It's a great tool. You can always just Google and find other practice problems on the web or whatever. But yeah, if you understand everything we did in this video, you're going to do perfect on your test. All right? Thanks, guys.